Kia ora everyone, thank you for being here today, and thanks to the OPC for having me along for my presentation, which is entitled Secure by Design. So this is a talk about how to think about, design, and build secure software. So a little bit about me. Historically, I have worked at a few logos, fairly varied and diverse background before I started in cybersecurity. Worked in a bunch of different places as a software developer, as a print controller at the International Film Festival. I did my own thing for a long time. Once upon a time, I was a software developer. I was also lucky enough to speak at DEF CON last year, which is one of the world's largest cybersecurity conferences, about some of our research into Microsoft products. I've also recently returned from Singapore, where I was presenting some of my research at a conference called Off by One. The Microsoft Security Reporting Center has a leaderboard for people who disclose vulnerabilities, and I was lucky enough to make it onto the leaderboard for Q1 and Q2 for some of the security issues I found. And I'm also a frequent flyer with the Cybersecurity Emergency Response Team, which is now part of the National Cybersecurity Center. The world's greatest incident responder works there. Also a little bit about me. I had a life before tech and security and privacy related things. I used to tour a lot of bands to New Zealand. I have a lot of trauma and I've paid off all my debt from that time, which is quite reassuring. But this was a very interesting time. I didn't actually have a frontal lobe at the time because I started when I was 23 and I made some questionable decisions. These days, I am a security researcher, which means that I find and report things. I also do something called bug bounty, which is I find and report things and companies pay me money for it. I also have a day job where I do something similar, where I find and report security issues for work. Essentially, my job is taking the unhappiest path through what I am working on, similar to an advanced persistent threat group who do the ransomware stuff. So sometimes that's internal networks, sometimes it's web applications, mobile applications, that sort of thing. A little bit of a disclaimer. I am a security person who enjoys privacy. I really respect and love privacy and also the work the OPC does. And the angle I'm coming at it from is cybersecurity can help to protect digital privacy. So we're going to talk about some things. The first thing I'm going to do is make some definitions and define some things. So some of the more technical things will hopefully have a little bit of a shared understanding before we go into it. We're going to talk about threat modeling. We're going to talk about the confidentiality, integrity, and availability triad. We're also going to talk a little bit about the software development lifecycle, which will be very familiar to anyone who's a product manager or a QA or works in that space. And we're going to have a few case studies of how some fairly insecure designs can get you in trouble from a privacy and confidentiality perspective. So I'm going to show some examples of insecure design in the wild. And we're going to talk about some byproducts of moving fast. A lot of you will have heard the expression move fast and break things. Well, things can definitely break in a fun and exciting way. And we're also going to talk about one of my favorite subjects, which is Microsoft. So you want to build secure software. This is a relatively difficult thing to do sometimes. There are lots of ways that we can do it, and we're going to talk about some of the common techniques that we can think about. So a really important thing to do when you start building software is get the basics right. And this is true of lots of different industries. So the first thing we're going to talk about is what encryption is at rest and in transit, meaning is it on a hard drive somewhere or is it moving around? How logging is effective and how it's used, and also the importance of redacting logging to protect personal information. We're also going to talk about inadvertently exposing developer, and test environments to the public internet. So once upon a time, my partner said to me that I was a person who moved pixels for a living, which was technically true. And at that point, I pivoted into cybersecurity because I realized I didn't want to move pixels anymore. But some more things to think about. The idea of allowing users to delete their data, maybe an audit could help, and notifying users when data is collected. And obviously the Privacy Act has some fairly clear guidance around that. And I will acknowledge, having been on both sides of the fence as an offensive security practitioner and also a software developer, it's not easy to do. Anyone who's ever worked for a startup or an organization moving at any kind of pace, there are commercial pressures. Your product manager might come up to you and say, our competitor has just released something, we need a proof of concept out tomorrow, and you might deploy some code that might live on your website for the next 5 years. And there are various contexts and pressures that can lead to less than ideal outcomes when creating software. However, getting the basics right will get you a long way, and there are lots of ways to get them right. And we just have to try. There's not really any excuses in 2025. So some things we're going to define. The first thing we're going to talk about is encryption, and then hashing, and then everyone's favorite version control software, Git. And we're going to talk about the concept of threat modeling and also about security controls. So encryption is something that's been around for thousands of years. Sometimes two parties wish to communicate securely and privately. It's one of our oldest technologies, and just here is an example of something called a Caesar cipher. Some of you might remember this from school, where you have your plaintext ABCD, and then you have an offset cipher, and it's just a one-to-one mapping which you can use to decode or encode various things. Encryption in 2025 is slightly more complicated than a Caesar cipher, thankfully. And there are two main types in use. There's one called symmetric encryption, which means it's the same key for both encrypting something and decrypting something. And then you also have something called asymmetric encryption, which is public and private key pairs. And this allows for secure key exchange, so two parties can communicate. If the public key is known, you can encrypt something with it. This here is the Cloudflare lava lamp wall, which underpins a huge amount of the transport layer security and encryption in the public internet. So how this works is they have a bunch of cameras trained at the wall, and lava lamps are extremely random. And one of the things you need to encrypt things properly is a lot of entropy or randomness. So they get approximately 100 megabytes a second of entropy from this wall, and it powers, 20 to 30% of the internet, I'd imagine. Please don't check that number, but it's quite a lot. Another thing we're going to talk about is hashing. So hashing, as one of my network engineering lecturers described it, is like turning a cow into sausages. So what this means is if you turn the cow into sausages, it's very hard to turn the sausages back into a cow. So mostly you can't get the data back. It's known as a one-way function. So whatever you put in, it comes out at the end of a hash function as some hash text. And this hash text is of fixed length, so it doesn't matter what the size of the input is, the hash at the end will be the same size. And this is used to store passwords securely, which, so it means that if a data breach happens and a password hash is stolen, it's computationally difficult to get the data back. There are techniques you can use to brute force against known data breaches in word lists. So it's not a perfect solution because humans are predictable, password 123, welcome 12345, that kind of thing. And on any mid to large organization, we might be able to recover by brute forcing between 20 and 50% of passwords. It really depends, but it's just one of the many security controls, which we'll talk about later. So Git is what's known as version control for software. So when a developer writes code, it's kind of like track changes. They make commits and it records what has changed, and it shows a diff, which is the difference between two states. And nothing really disappears from Git, but we'll talk a little bit later about where it can end up and why that's a bad thing. So threat modeling is a relatively straightforward concept. It's just an idea of understanding what your risk profile is and what sort of threats are out there. And this is straight from the Microsoft software development lifecycle threat model. So you define your security requirements, which basically means what are we worried about? How do we want to protect the thing? And then you create an application diagram, and you might include the security controls, you might include any kind of network, you might include things like passwords or MFA. You identify your threats, which means we're worried about nation states, we're worried about inside actors, and then you come up with mitigations for the threats. How are we going to protect against these things? And then you do some testing or some review to validate that the things you're worried about have been mitigated. So how this looks in practice, it really depends. Sometimes, Agile is involved. Sometimes Jira is also involved. And when I first started as a software developer, a friend of mine who didn't really like Agile all that much described it as a cult, and he described sprints, which are the chunks of work that you do, as a death march. It's not quite that bad, but yeah, Agile, it's a thing that exists. So the software development lifecycle is a methodology that helps people build software. So you start with your planning, and then eventually you deploy something onto a website. Different organizations do this in different ways, but the basic life cycle looks something like this. So a product manager might have identified a gap in the market for something. They might want to implement a feature that the competitor has done, or they might want to make a new feature that is new and exciting. And so they would gather some requirements. This might be a business analyst doing this. It could be a designer doing this. And what requirements gathering is just a basic understanding of what you're trying to achieve. And then from this point, you go to the design phase of things, which is where a designer will sit down with a business analyst. They have all the requirements, and they'll turn it into either wireframes or some way of, for a developer to understand and code it, which is the next step. So a developer will take these designs and these requirements, and they will write some code. And at some point, this code will make it to a dev or a test server, development or test server, and then a QA or a functional tester of some type will hopefully test it to make sure that the requirements have been met and it matches the design. And obviously QA is very, very good at finding edge cases that will break things, and I love them for this. And then eventually it will get deployed to the website and people will start using it. So quite often, and this is one of the biggest things I've seen in the SDLC, the software development lifecycle, is people will go from all the way through the lifecycle. They will, make this magical thing, and then they'll just say, hey, we're going to get a penetration test or some security auditing after we've done. And a lot of the times we see this in action. It can derail projects for 3 to 6 months as security issues are addressed. And there are some ways to get around this. So one thing we encourage people to do is threat model early and often. So what this means is in the early stages of your design, try and front load your threat model, try and understand your security requirements before you start writing code. You'll save money and you'll save time in the long run. Because as anyone who's ever shipped code, sometimes it can be hard to unpick, not impossible, but the more code you write, the more code you might have to change down the line. Another thing we're going to talk about is what's known as the CIA triad. So this is confidentiality, integrity, and availability. So I'm only going to really talk about confidentiality and integrity. Availability is, whether you can access something, but confidentiality is talks about and it governs how information is accessed and how it is disclosed to things. Pretty important in the case of a data breach. Integrity is whether information is modified or whether it can be destroyed. So these are the two that fall broadly into the privacy camp. So it's a framework that helps cybersecurity professionals identify risk. It also helps us keep data private because by measuring things with this framework, it also helps us to classify bugs such as CVEs. A CVE is known as a common vulnerability and exposure, which is a known bug. So recent examples of CVE will be something like Log4j, which happened a few years ago, which caused a whole heap of stress among the blue team, which is the people responsible for securing software. There was also one about 10 years ago called Heartbleed, and there was also some ransomware ones. I think Eternal Blue was one of them. So there's a lot of known CVEs, and I'll talk about some of the ones we found in Microsoft a little bit later. So another concept that we have in cybersecurity is security controls. So a lot of you might have heard about the Swiss cheese model. It applied to COVID protections. It also applies to cybersecurity. And what that means is you have several layers of defense. So if something comes in, it might get stopped at any one of these layers. So some security controls that are really common. A password is a very good one, and that's a very important one, as your IT team will no doubt tell you. Microsoft has its own idea about security controls, and they will provide warnings, and we'll talk a little bit about that later. And multi-factor authentication is a great security control, and they work really well with passwords because passwords are what you know, which is do you know the thing, do you know your password, and MFA is what you have, and between those two things, it's a fairly robust security control. And what I mean by what you have a device or a YubiKey or some sort of hardware token that, it's a physical component. And there are also physical controls. Some of the common physical controls we see are quite obvious, locks on doors. And sometimes we have network controls, which means can the corporate network at your workplace see the server network? And the answer should hopefully be no. You might need to go through an intermediary, such as what's known as a jump host. So lots of different security controls. Warnings are my favorite. Thank you, Microsoft. So we're going to talk a little bit about some insecure design and how it has got some organizations almost in trouble. But, you know, I'm a see something, say something kind of guy. And so the first one we're going to talk about is when an intranet goes into and how some passwords were insecurely stored. And we'll talk about that later. So I was doing a penetration test. We're doing what's known as an external review, which is where we sit on the public internet and we just see what kind of footprint an organization has. So when a computer or a server is sitting on the internet, it can expose anywhere up to 65,535 ports. The ones we care about are 80, which is HTTP, and 443, which is HTTPS. These are commonly known as the internet ports. So we're doing a pen test and we were going wide and we're trying to figure out what has been exposed. And an organization had piped their entire intranet out to the world. And this was an organization that hundreds of thousands of records were accessible, including a clear text username and password for a domain joined user, which we're then able to use to log into the VPN, which didn't have MFA. And they shut that down within a matter of hours. They had to find where it had happened, but I think it had happened over COVID. Obviously, with people working from home, they needed the intranet accessible. They might not have had a VPN set up. These things happen, wasn't ideal, but the network design had meant that it was exposed to the whole internet, not just a subset of users. So this essentially is what happened. Their intranet was piped out to the world. So we've talked about passwords and hashes and how a password can have a hashed representation. Usually, hashed passwords are in a database somewhere. And this is a good thing. There's a lot of security controls between a web application server and a database server. There's usually network controls. Databases aren't exposed to the internet. You need to compromise the web server in order to get to it. However, there are times when databases aren't used. Sometimes things are just put into files, which is okay also, depending on, you know, the controls around it. And different servers like Apache or Tomcat or different web application servers will show you different file types depending on what it is. And there's a type of file called XML, which is a very Windowsy file type, also used in Linux. It's short for Extensible Markup Language, very similar to HTML. And so on this job, I found a file that you could visit in a browser, which was simply called secure.xml. And when you visited it in a browser, it looked like this. And so it had the username and the hash of the password, and the passwords itself were in a form called MD5, which is a fairly weak hashing algorithm. Lots of reasons it's considered weak, but about half the passwords had already been brute forced. And so you could just Google any one of those hashes and find the clear text password. So this was in local government. And the thing about local government software is if one organization is using it, chances are several hundred also are. So this was the first time I'd ever disclosed something to the Cybersecurity Emergency Response Team, who now part of NCSC. They exist to help with this sort of thing. So I rang the client immediately and said, hey, we've got some password hashes sitting in WebRoot. We can Google some of them and get into the application, or we could try and crack them if we wanted to. And there are approximately 220 organizations impacted. We quantified this in a number of ways. And so from here, we did the responsible thing. I notified CERT, who are able to send out a targeted advisory to all the impacted organizations. They also spoke to the Australian Signals Directorate, who perform a similar function in Australia. And the Australian Signals Directorate also identified who was affected and sent out a targeted advisory. And while this was happening, I also contacted the vendor who had created the software and said, I'd like to disclose the security issue. And so I got on the phone with a product manager, and he said, oh, this is just how the webmasters have set it up. It's not our problem, it's just a configuration issue. And I helpfully pointed out that it was also on the ones that they had deployed themselves. But, you know, I've disclosed it, what else can I do? And the following day, the product manager called me up and said, we've had 30 local government organizations call me asking about this issue, we're patching it tomorrow. So CERT and the Australian Signals Directorate had done a really good job getting out the advisory. And so it was able to be patched and rolled out extremely quickly, which was perfect. So there are some byproducts of moving fast, and breaking things are obviously one of these. So if you're lucky enough to work at a 21st century software development shop, you'll be able to ship code several times a day. And what this means is you'll write code, you'll put it into the version control system, and you might make a pull request, which is a review process where a more senior developer or other developers can review the code, make sure everything looks good. Then you hit a button, and in an ideal world, 1 to 2 minutes later, 10 minutes, it might be on the website live, which is awesome and a wonderful way to build and create software. It makes you feel like you're doing stuff. Sometimes, however, things are left over from this process. And this really depends on the process itself. So they're known as deployment artifacts. So these deployment pipelines, you write the code then runs on the website. So sometimes things are left over. This might be secrets or what's known as environment variables, which are little bits of data that the server needs to know about. It might be a database password. It might be an encryption key, like a token. And these might be written to disk. And so occasionally we see these things being written to disk, which are then accessible on the web server, which was certainly not the intention. And a really common one that we see is the Git folder in the root of the web directory. And what the root means is like index.html, that's in the web root. The first thing you see when you visit a website is the web root. And so we've seen a lot of Git in web root, which isn't great because it means you can download and reconstruct the source code. It's essentially like leaving a sensitive document with track changes just in a folder on a server. People do actually put a lot of secrets in code. And we've also seen a lot of various XML, extensible markup language, and JSON files, JavaScript object notation files, which are very readable, and they often have clear text secrets, which were written out as part of the deployment process and not deleted. So yeah, sometimes the side effect of moving is deploying things and leaving things where they shouldn't be. So another thing which is very, very good, and we touched upon it briefly, we talked about the Cloudflare entropy wall. Encryption is a great thing. There's a lot of things that use encryption. HTTPS is one, FTPS, the secure version. So this is transiting things around. It means end-to-end encryption. WhatsApp has started doing it now. Signal's very, very good at it. It means from your handset to someone else's handset, no one can intercept, or even if they could intercept the messages, they couldn't decode the clear text, which is really great. And so some key exchange takes place in order for that to happen. And you can also encrypt things at rest. So sometimes you can have something called blob storage, which is just a server on the internet that can store files like S3 buckets or Azure blob storage, or you can encrypt things in the file system on a server itself, which is really good. So it means if someone has physical access or another kind of access to the server or computer, they're not going to be able to do anything unless the key is stored there, but they're not going to be able to do anything to decrypt the file. So this is really good. And this is becoming much more common in cloud environments. There's some more secure defaults rolling out around encrypting things at rest. Logging is something else that we're just going to define quickly. So logging is a file or a database that logs activities of things that are happening. So this is generally really good, particularly if you have a response situation. In the case of a data breach, you need to be able to look at your logs. They're basically time-stamped entries of things that can happen. However, sometimes logging and analytics can leak personal information. I've seen Google Tag Manager sending all sorts of things places before. Some organizations are very good at scrubbing this data, but there's always stuff being sent that you might not necessarily know, and sometimes that data might be sensitive and you don't want it being sent upstream to a third party. So thankfully, both Azure and AWS, Amazon Web Services, now offer something called log scrubbing, which you can define personal data and then you can just remove it. However, sometimes other info that might not necessarily be personal might make it into logs. And so what possible problem could there be? Over last week, I was in Singapore at a conference over there called Off by One, and a fellow researcher called Sergey hacked something called a Xiaomi S3 smartwatch. So this smartwatch is fairly standard. It's a watch. It has a lot of sensitive information in it. It has all your emails in it when you download them, but it has a 6-digit PIN protecting it. So if you had physical access to the device, you could dump memory, which is the memory of the device, and you could dump some logs. But none of these things contain the PIN. So far, this security control is still reasonably effective. However, sometimes logs are enough. So this is what a log for a watch would look like. So here we've down the bottom, we've got a couple of lock screen manager verify PIN succeeded to verify. And what this means is someone successfully entered a PIN and was able to unlock a watch. So far, so good. Let's have a look at some of the entries that led up to the watch being unlocked. We have something here called a TMA 525 PARS touch report, which looks like X and Y coordinates. So if we back it up even more, we realize there's quite a few presses and releases on certain coordinates before the watch unlocks. And if we figure out what the X and Y's are, and figure out where they are, and then we put them roughly on the watch, and we know what order they happened in, you can get full PIN recovery. So sometimes logs will log things that may lead to compromise, not necessarily personal information. So that was a pretty cool hack I saw last week, which was disclosed and fixed by the vendor. So we're going to talk now about developer and test environments. So this is one of the biggest threats we've seen to a lot of organizations. Everyone here will have seen production data existing in test environments. This is a really common thing, often because the quickest way to create a test environment is to give it prod data. However, security controls for these environments are frequently weaker. On a previous pen test I was working on once, during scoping for the test, the boss had typed demo into one of the platforms, and sure enough, that was an acceptable username and password, and it resulted in compromise of 3 servers at the end of the chain, and it all started with demo. So things like demo, test, password 123, default security credentials, these things are really common in dev environments. And so it's something we always encourage people to be very, very careful around and make sure there are more appropriate security controls in place, particularly network ones, meaning that they're not necessarily on the public internet. There are things known as external acceptance and testing environments, EAT environments, and they're okay to be on the public internet because sometimes, well, it depends, but you might have third parties testing them, so they may need to be out there. But it's just something to think about when you're deploying something and it's going on the internet. People are going to be wiggling the doorknobs constantly. So another thing to think about when you're building software is be encouraging of audits. So I was talking to Petra Smith, who is a former security consultant, and she told me about Kirchhoff's principle. And Kirchhoff was a 19th century cryptographer, and he basically said a crypto system should be secure even if everything about the system except the key is public knowledge. So one thing we've really found when dealing with vendors is it's a real mixed bag. Some vendors say no source code, this is our proprietary software, it's obfuscated, you can't decompile it. And a lot of people will try to obscure things. And so there are similar concepts that date back further. And one of them goes back, I think, to about the 15th, 16th century, which is even if everything about the lock is known, it should be secure. And so this can apply to building software in the 21st century. A lot of people still try to obscure things or bury things within code or do something smart that may eventually unravel for them. So Petra had a really great talk, a very brief history of safecracking, specifically in Aotearoa, New Zealand, which is available at the end of this talk. There's a little link there. She did it for CHICON, which is a Christchurch-based security conference. Another thing we like to do to help people build private and secure software is audits. And one thing I'd really like to make clear for anyone who's ever getting an audit by a cybersecurity company, we're not here to make you feel bad. We know things happen. We're just here because privacy and security is a team sport. And one thing we try to do is prioritize collaboration over confrontation. And I know that security often gets a little bit of a reputation for calling things dumpster fires or using very similar unhelpful language to describe things. I hate that, it's awful. We have the same end goal. We want a safe and secure New Zealand digital space. So another thing you can do if you're building software, and the Privacy Act is obviously very clear on this, you need to take reasonable steps to notify users when data is collected. One of the problems with a lot of websites is maybe they don't necessarily have a privacy policy. Lots of big public websites do, but lots of little ones don't. And so if they're collecting cookies or other session information, and I talked a little bit about this in my talk last year about a hacker's view of data breaches, about how and why information is collected. Yeah, this is something to think about. You need to let people know yeah, whether you're taking information or sending it somewhere or where it's going. And so there's a lot of metadata that can paint a pretty good picture of who someone is, etc., particularly with tracking pixels from Facebook or Google tracking or TikTok tracking and that sort of thing. One thing I feel very strongly about when creating software is giving users the option to delete their data. And I don't just mean a soft delete, and sometimes it's not possible, particularly with Xero, if there are legislative requirements around keeping records, particularly with the IRD. That doesn't count. They need to keep it. But when you deactivate your account, is it really gone? And the answer is probably not. It's probably in a backup somewhere. I deleted my Twitter account about a year ago after all the stuff happened. And I can't reactivate it, which is great, but I strongly suspect somewhere on a server or in a Glacier storage, there's still bits of my Twitter account and data there. So another big issue that we're starting to see in cybersecurity, artificial intelligence, large language models, people have started using this to develop code with interesting results. So the basic premise of AI is garbage in, garbage out. James and Andrew did a great talk a couple of days ago about some of the impacts of artificial intelligence, and they coined the term TEThics, which stands for technology and ethics, which was wonderful. But also the blatant disregard that the AI harvesters have for privacy is quite shocking. As James pointed out, they've got to the end of the publicly available stuff, and now they're sort of wanting to get all the private data sets. They don't want intellectual property to exist in any meaningful way, which feels like a very bad thing. So vibe coding, as some of you may have come across, essentially it's using the plagiarism machine such as ChatGPT or Cursor to write some code and deploy some code. So let's see how this works. This poor person called Leo built a SaaS company. They built it with Cursor, no handwritten code. And they went on, I think this is X or Twitter, and they went on X and said, AI is no longer just an assistant, it's also the builder. And this is typical kind of startup bravado. You can continue to whine about it or start building. And so they made this, got a few retweets. And then a little bit later, guys, I'm under attack. Ever since I started to share how I built my SaaS using Cursor, random things are happening. So yeah, this person admits to not being technical, so they can't figure it out, and finishes off by saying, there are some weird people out there. And yep, but this is pretty common. If you deploy code that you don't understand, you're opening up what's known as an attack surface, and people will start messing with your stuff. So finally, on to my favorite subject. This was what we ended up talking at DEF CON 32 in Las Vegas last year about, was a bunch of exploits we found in Microsoft and reported to them. So Microsoft, as we all know, has a lot of security controls. And these security controls is mostly an alert or a warning. And this is their primary don't hack me. So everyone will have downloaded a document from the internet, and something called the mark of the web will be applied to this document, which will basically be don't fetch any external resources and don't execute macros. So you usually have to click through a whole heap of warnings, or one or two, in order to be exploited. And so instead of making the software not really exploitable, they just have warnings, which is probably what the legal team wanted. And this is what they look like. Microsoft Office has identified a potential security concern. This location may be unsafe. http://microsoft.com. So here the security boundary shifts. They make the user accept risk for and responsibility for this. And this is a liability issue. Before someone gets their entire organization ransomware and data breached, sometimes they'll have to click through one of these. The good bugs are when you don't have any security warnings. And so I'll talk about that in a little bit. So we've talked a little bit about password hashes, the representation of a password. Microsoft has a very special flavor of them, and this is called the New Technology Land Manager password, which was made in the 90s and is still around. So when you access a file share, such as in SharePoint or on your local network, these NTLM hashes are used to authenticate to the file share. It's just a way of saying this user can access this resource. So Microsoft has been trying to deprecate these since 2010. It isn't going very well. Most environments we've looked at still have this enabled. For legacy reasons, Microsoft is generally very good at backwards compatibility. And so they've finally drawn a line in the sand and they're turning it off by default, I think from Microsoft Server 2026. And I think Windows 11 is starting to ship by default without it on, which is a good thing. Some organizations may re-enable it, depending on what they need to access within their environment. So it's a pretty bad technology. It's known and loved by advanced persistent threat groups, the ransomware actors, the people who love to cause the data breaches and just generally be pests. So these things are not just a password. You don't necessarily need to crack them. If you are in an internal network, you can relay them around and impersonate users within an organization. And there's a lot of techniques for doing this, but also you can attempt to brute force them offline against known word lists. So we came up with some techniques to fish for them as part of this research project that we presented last year. And in the words of Metal Storm, who used to work at Insomnia, POC or GTFO, POC obviously stands for proof of concept and GTFO stands for something else. So our techniques that we came up with bypassed all security controls. So it bypassed safe links, which is the thing that runs away and checks a link. It bypassed mark of the web and it bypassed all antivirus. And so what I'm going to show you next is a demonstration of one of these techniques, which leveraged Microsoft Office and the lack of warnings within Outlook to successfully force authentication and capture someone's password hash. So hopefully this video plays. Cool, so we're spinning up a little server in the top right corner there, and then we're setting up a rogue authentication server down here, which will provide an authentication challenge. And then we click a link and some Microsoft Word opens, no security warning, some other stuff happens. And then in the bottom right-hand corner, you'll see successful capture of my colleague Thomas's credentials just after clicking the link. So once again, Microsoft's security warnings were non-existent. Mark of the web didn't apply because it didn't even download a file, and antivirus wasn't triggered because these are perfectly normal interactions. So we submitted this to Microsoft along with 3 others. And most of these were patched in August and September 2024. And we had multiple CVEs assigned and got to talk about our research multiple times. So we've seen some real world examples of design failures, and we've seen some relatively common techniques to try and create secure software. What now? If you can take one thing away from this, it's front load the effort when you're building software. It's like so many things. Upfront thinking and planning can save you a ton of hurt down the line. Things like design reviews, threat modeling, and just getting the basics right will get you 90% of the way there. The rest of it will take a lot less time if you get those things up front. Cool. Speed ran it a little bit, sorry. So we do have some time for questions, which is good. We've also got, we've got some questions in the Q&A. Oh yes, the first one is, as privacy people with somewhat little influence, understandable, security people feel similarly, we often run into the issue where business areas are not willing to create test data for testing and insist on using production data, citing low risk for various reasons. How would you recommend we counter that? That's a really difficult one. There are tools that are available to obfuscate data, but also it's not as hard as you would think. A lot of the time it is just creating a database. I would ask them for a detailed response of why it's so difficult, because development environments often have, when you're developing on your laptop, sometimes it uses prod data, which is definitely not great, but sometimes you have scaffolding scripts which will build up and populate tables so QAs can test things. And a little bit of upfront effort in creating these tools to kind of populate things will have some long-term kind of things. So just ask them how hard it is and what the technical reasons are or what the difficulties are, because it shouldn't be hard. And if it's hard, they might need to reassess their development processes. Anonymous attendee has, are you aware of security chaos engineering by Kelly Shortridge? Is this like the chaos monkey thing, I think? I have to look that up, but I have come across similar concepts, which is throwing spanners into things and having lots of chaotic things happening. I like it. It's a good way of testing responses and systems. It's good. No question, but thank you for speaking at a level that a non-IT person can understand. Thank you. This is something I really like, is demystifying some of what we do in cybersecurity. A lot of the things we do are not particularly complicated. Sometimes you have, more technical things, but a lot of the issues we see are relatively straightforward. I never want to use the term easy because I don't like that. But yes, I try very hard to make things accessible because cybersecurity is for everyone. Are there AI apps for pen testing? Absolutely there are. And in your opinion, could they be better than human testers? I'm going to go ahead and draw a wee line in the sand here and say absolutely not. The main reason for that is because large language models are not capable of cognitive leaps. While they have their place, and I know that some people are using them, I certainly wouldn't put any level of trust in a large language model. A case in point is bug bounty programs are absolutely flooded with bogus vulnerability reports at the moment. It's a really big issue. The creator of a tool called Curl has basically come out and said anything that looks like it's created by AI will be dismissed immediately because the LLMs have been creating completely fabricated and made up garbage that looks convincing. So not at this stage. And also, I would say it's a limitation of the technology, but I'm happy to be proven wrong. Let's see. And another anonymous attendee says, is the presentation available for viewing later on? Absolutely. Ray and the comms team have been doing an excellent job at publishing things to YouTube within the next day or so. Can an expert like you curate AI created code? Not sure what you mean by curate, but I can read it and understand it. So yeah, it really depends. I mean, I would be very careful about using AI created code if it was anything longer than a few lines. Thank you, Tina. Thanks, Jim. Great talk. Hillary asks, thank you. If your business is developing a database using existing software, what are the key things we should expect from the developers or BA to ensure we have dotted the I's and crossed the T's in terms of security? Some really good things to think about is if there's an existing database, just making sure that's well segmented, meaning that only from a network position, only the computer or the server that should be able to access it can see it, making sure that, again, encryption can also apply to databases, making sure any passwords are hashed, that sort of thing. Yeah, there's a whole heap of things. Feel free to hit me up on LinkedIn. I can send you some slightly more detailed answers. It really depends on the use case, but yeah. Anonymous attendee says, as a security friend who is interested in privacy, what would be the one thing that you think privacy professionals should make sure they understand about security or that we could be doing to better support our cybersecurity and digital friends? Great question. I will have a wee think about this. Yeah, security is a team sport, just like privacy. And just making sure that we understand each other's professional opinions is a really good starting point. We all have different risk models and different threat models. And so making sure that we have a shared understanding of what is collectively important is a really good starting point. Yep, anonymous attendee has helpfully put in some security chaos engineering links for security chaos engineering. I will go and have a read. Yeah, easiest exploits from an attacker perspective. I'll go look at that. Anonymous attendee has a great question. I'm facing a challenge in getting developers on board with learning more about the security development lifecycle. Do you have any advice on how to address this reluctance without resorting to disciplinary action? Any insights on effective strategies for fostering a security conscious mindset would be greatly appreciated. For me, I would say try and make it relevant and fun for them. There's lots of online tools where they can learn how to hack web applications. And so putting them, whether it be Try Hack Me or Hack the Box or Pen Tester Labs or any one of those things, some are free, some are paid. There's also secure development training that a few people offer around town, which is basically when we sit in a room with developers and we spend a day taking them through the OWASP top 10 and teaching them how to hack a very poorly put together web application. So turning it fun and making it contextual for what they're actually trying to do is a really, really good starting point. And just demystifying it to some point. And, they don't need to know that it's incredibly complicated or difficult to do. There are some very effective and straightforward things that you can do. But yeah, that's a really good question. As a developer, I didn't care all that much about security. Yeah, and Tina has also said role-based training for developers as part of the company-wide security awareness. Yeah, these are all good things you can be doing. Thank you for the feedback, anonymous attendee. Cool. Yeah, I'm available on LinkedIn if anyone wants to, befriend me on the commercial health site. We're on at Facebook. And also please go and watch Petra's talk about a very brief history of safecracking. These slides will be available. I'll be sending them to Ray, who's one of the wonderful comms people at OPC straight after this. How can a recent graduate get involved with a bug bounty program? Any recommended platforms? Really depends. Next, shameless plug for the next couple of months, I will be talking at Wellington's ISIG. I will be giving the talk that I delivered in Singapore, which is called Bug Bounty, My Cottage Industry of Crime, which talks about my security research and bug bounty stuff. In terms of platforms, HackerOne is a good place to start. BugCrowd, Integrity, and Microsoft are the four that I tend to hunt on with varying degrees of success. But yeah, have a look on the bug bounty Reddit forums as well. There's some pinned threads there about how to get started. And also don't be discouraged if you don't find anything. You need to find your own path to be successful at bug bounty. But great question. Cool, it looks like we've come to the end of the Q&A. If there's anything else, yeah, feel free to flick me a message on LinkedIn. I'm fairly accessible online and happy to answer any offline questions that you might have.